Hello everyone, welcome back to the channel Code with AKJ. Today is day 38 of solving Geeks for Geeks problem of the day. Today we'll dive into an exciting string based problem. It's longest prefix suffix. So it's a common problem that comes up in a technical interviews and tests your knowledge of string manipulation. So we'll explore both brute force and optimal solutions, and so let's get started. So the question says here, given a string of characters, find the length of the longest proper prefix, which is also a proper suffix. Prefix and suffix can be overlapping, but they should not be equal to the entire string. So we are given a string and our task is to find the length of the longest proper prefix, which is also a proper suffix. So here a proper prefix is a substring from the beginning of the string and a proper suffix is a substring from the end of the string. These can overlap, but they should not be equal to the entire string. So let's take a look at these two examples to understand. Here the string is ABAB and the proper prefix and suffix here would be AB. So we need to return the length of that particular longest proper prefix and suffix. And coming to this example, here the proper prefix and suffix would be AAA. And we need to complete this problem in O of length of string in time complexity and O of length of string in space complexity. So let's start with the brute force approach. The brute force approach idea here is to check all possible prefix and suffix pairs and see if they match. So we'll start from the longest possible length and we'll move towards the 0. And the key idea here is to make sure the prefix and suffix do not overlap more than necessary. So let's understand these two examples and we'll create all the prefixes and suffixes of these two strings and we'll match and we'll return the length of it. So here's the brute force approach idea. I have taken these two strings. I have written these two strings prefixes and suffixes. So coming to this example 1, the prefixes here would be ABA and BAB, which is of length 3. So we'll compare if they match or not. So here they don't match. So we'll move on to the next length, which is length 2. So the prefix of length 2 would be AB and suffix of length 2 would be AB. We'll again check these two prefix and suffix. Here, since they are equal, we'll return the length from here itself. So in this case, our answer would be 2. So coming to the next example, the string is AAAA. So we'll start from length 3. So the prefix here would be AAA from the starting point and the suffix would be AAA. Since they are equal, we can return the length 3 from here. So in this case, our answer would be 3. So let's code this approach and we'll move on to analyze our time complexity and space complexity. So this is a code for the brute force approach we have discussed. Here I have taken the length of the string. I have iterated here from the end of the string and I have calculated both prefix and suffix and we'll match these two string values. If they are equal, we'll return length from there. And finally, if we didn't found any prefix or suffix, we'll return 0 from the main function. So let's compile and run this. So let's submit. As you can see, this gives us time limit exceeded. So in this code, we use the substr function to compare the prefix and suffix for each possible length. So if they match, we return the length. So here the time complexity of this approach is O of n square because the substring function takes O of n time to check for each length. So now that we have seen the brute force solution, so let's move on to the optimal approach. The brute force approach works fine for smaller strings, but it will struggle with larger inputs due to its O of n square time complexity. So can we do it better? Absolutely. To optimize this, we can use the concept of KMP algorithm, where the idea here is to build a prefix suffix array that will allow us to calculate the longest prefix, which is also a suffix in O of n time complexity. So this array will help us to calculate the longest prefix suffix length, and here LPS of I represents the longest prefix suffix length at that particular character I, which means at particular character A what is the length of the longest prefix suffix, and the same goes with at character B what is the longest prefix suffix length. And in this way we'll calculate at each and every character what is the longest prefix suffix array length, and finally at the end of the array we'll get our maximum longest prefix suffix array length. So let's try run these examples and we'll move on to the code later. So our steps here would be to create an array that will store the longest prefix suffix values for each index of the string, and we'll initialize the first value as 0 because the first character can't have any prefix or suffix. We'll also take a help of a variable which is previous longest length, which will be initially at first index, and we'll take a current index I, which will start from index value 1. So now let's start our approach and let's try run this example. So we'll compare these two characters. If they are equal, we'll move this index value to the next pointer and we'll update the length with our previous pointer. So in this case, the characters are not matching. So if character doesn't matches, we'll check the previous longest suffix length. If it is pointing at initial index 0, we'll update this current index I with 0 and we'll move our index value to our next character. So now let's again compare these two characters. Since they are matching, we'll update this previous longest suffix length to the next pointer. We'll move this and we'll update this length with this previous longest suffix length index. So here, since it is pointing to the index 1, we'll update the length here 1. So here 1 indicates that at this particular character we have a longest prefix suffix array which is of length 1. So after updating this LPS of current I value, we'll move this I value to our next index. So now we'll again compare these two characters and we'll follow the same process. Here, since these two characters are matching, we'll move this previous pointer to the next index. We'll update the LPS of I value with this index, which is 2, and we'll move this I value to the next index. Since I moves out of this array, we'll stop the iteration and we have created our LPS array values and we'll return the end value, which is our longest prefix suffix length. So in this case, our answer would be 2 and the prefix suffix value would be AB. So coming to the second example, so again we'll start with this previous and current index I, which starts from index 1. So we'll compare these two. Since they are equal, we'll move previous to the next pointer. We'll update this I value with the previous pointer's index, which is 1. So I've written here 1 and we'll move I to our next index. So again, we'll compare these two characters. Since they are equal, we'll first move previous to next index. We'll update the I value to the previous index value, which is 2, and we'll move I to the next pointer. So again, we'll compare these two characters. Since they are equal, we'll move previous to the next index and we'll update this I value, which is the previous index pointing, which is 3, and we'll move I to this next index. Since I is out of the array, we'll stop the iteration and we'll return the last index value, which is 3. So in this case, our answer would be 3, which is our length, and the string would be AAA. So let's try to take a larger input string and we'll do this whole process again. So initially the value would be 0 for a single character. We'll start iterating from index 1. Now let's compare these two characters. Since they are not equal, we'll check the previous suffix length pointer. Since it is pointing to the index 0, we'll update this current index value with 0 and we'll move this I value to the next pointer. So let's again compare these two characters. Since they are not equal and our previous pointer is still at index 0, we'll update this character's length 0 and we'll move this index to the next pointer. Again, we'll compare these two characters. They are not equal, but our previous pointer is still pointing to index 0. We'll update this length with 0 and we'll move our index to the next pointer. Since here still they are not equal and previous pointer is at 0, we'll update this length with 0 and we'll move this index to the next pointer. So here, since these two characters are matching, our first step would be to move this previous pointer to the next pointer and update this value with the index the previous suffix length is pointing. Since here it is 1, we'll update this value with 1 and we'll move this index to the next point. And let's again compare this. Since they are equal, we'll move this previous to the next index and we'll update this length with the index value it is pointing, which is 2, and we'll move this I value to the next pointer. So again we'll compare these two characters. Since they are equal, we'll move this previous to the next index. We'll update the length with the index it is pointing, which is 3, and we'll move this I to the next index. We'll again compare these two characters. Since they are equal, we'll again move this previous to the next pointer and we'll update this value with the pointing index, which is 4, and we'll move this I value to the next. So now again let's compare it. Here E is not equals to A. In this case, what we'll do is we'll set this previous pointer to the previous -1 value. Here the previous -1 value is 0. So here the previous pointer will set to this initial index 0. So now we'll compare these two characters. Since they are equal, we'll update this value with 1. We'll move this I value to the next and we'll again move this previous pointer to the next pointer. And again we'll compare these two characters. Since they are matching, we'll move this previous to the next index. We'll update this next index value, which is 2 here, and we'll move I value to the next index. Since I is out of the array, we'll stop the iteration and we'll return this value 2 here. So in this case our answer would be 2, which is AB string. So here the time complexity would be O of n and space complexity would be O of n, as we are using an external data structure array. So let's move on to the code and let's submit it. So this is a code for the optimal approach we have discussed, where we have used the KMP algorithm, and here we have initialized a vector of LPS initially, which is 0. Here I have initialized the initial value 0 as the first character doesn't have prefix and suffix. I have taken the prefix suffix length, which is initially 0, and taken the correct index, which starts from value 1. I have iterated the array, and if the character matches, we'll first increment the prefix suffix length and we'll update this length into our LPS of current index, and we'll move the index to our next value for further processing. And if it doesn't matches, we have two cases where we need to check the prefix suffix length pointer. If it is not pointing at the initial value, we'll move to its previous longest prefix suffix value, and if it is pointing at the initial index, which is 0, we'll update the LPS array with 0 and we'll move the pointer to the next value for further processing. And finally, after filling this array, the last value of the LPS array will give us the result. So we'll return the LPS of n-1. So here the time complexity would be O of n and space complexity would be O of n, which is our expected time complexity and space complexity. So let's compile and run this. It's working, so let's submit. As you can see, this problem got accepted successfully. And there you have it. We have covered both the brute force and optimal solution for the longest prefix suffix problem. So if you found this video helpful, make sure to hit the like button and subscribe to the channel for more coding problem breakdowns. Also leave a comment with any questions or problems you'd like me to cover next. So thank you for watching, and I'll see you in the next one.